Alright, this is lesson 1.12 of our Precalc 12 class. Unit 1 is called Functions and Transformations. Lesson 12 is called Piecewise Functions. In this lesson, we're going to learn about what is a piecewise function, how to read piecewise functions from different representations, and then how to evaluate piecewise functions from different representations. So a piecewise function is a function that has a different expression depending on different intervals of inputs. So, for example, if this is a piecewise function, f of x is defined as x squared if the input is a number less or greater than 0. Or f of x is equal to 3 if the input is equal to 0. So if the input is 0, then the 3 is just the answer. Or if you have f of x would be equal to this expression if your input was on this interval, a number less than 0. So as a piecewise function, it could be one of several expressions to evaluate, depending on what interval the input is on. So this is just an example right here. It could be two different expressions. It could be 3. It could be 100. Whatever. So for example, if I evaluated f of negative 1 on this piecewise function, negative 1 is our x value. It is less than 0, so we're going to take negative 1 and plug it into this expression right here, x plus 1. And we're just going to simplify. Negative 1 plus 1 is 0, or x plus 1 when x is negative 1 is 0. f of 5, so 5 is our input. It is greater than 0, so we're going to use the x squared expression to evaluate. X squared is 5 squared, 25. F of negative 1/3. Negative 1/3 is less than 0, so we use the bottom expression. Where's the 1? If it equals 0, f of 0, our x value is equal to 0, so the answer is simply 3. Take a moment, read through all these examples, make sure they make sense to you. Go ahead and pause the video if you want to do that right now, because we're going to move on. Alright, here's a graph. If I wanted to graph this piecewise function, I'm going to draw a couple graphs. First of all, an x squared would be a parabola that opens up. If the function is equal to 3, that's just a point. And then x plus 1 is a linear equation, so it's going to be a line on our graph. However, the parabola, the point, the line are all going to be cut based on these domain values right over here, based on these intervals. So we're going to graph a parabola for all x values greater than 0. All x values greater than 0 means all these numbers to the right of the y-axis. So we're going to draw the parabola only to the right of the y-axis. Note, it does not include 0, so we're going to do an open circle when x equals 0, where that would be on the parabola, and then after that it will be all closed. When x equals 0, the output is 3, so 0, 3 is a point on our graph, that's the red dot. And then we have this linear equation. Don't forget your y equals mx plus b, and don't forget how to graph that. I am posting that on the entry tasks just to make sure you remember, so have fun with that. And you're welcome for the extra practice. Anyways, to graph this one, this line is going to be graphed for all x values that are less than 0, which are all the x values to the left of the y-axis. It's going to be just a line that would intercept at the y-axis because it's plus 1, and then it's just x with no number, no m value, or the m value is 1. So it's just going to go up 1, right 1, or down 1, left 1 to create this line. It would contain 0, 1, but because 0 is not included, we're going to do open circle around the where x equals 0. So we have open circle for green, open circle for purple, and then we have a dot for red. Alright, so that's how you graph this piecewise function. We take a bunch of different shapes of graphs, splice them together based off of their x intervals. Some more examples. So here's a graph piecewise function. I can tell I've got 3 pieces to this piecewise function. I've got a linear piece, I've got a a point where if the input's -1, the output's -4. And then when I have x values that are -1 or greater than -1, it's going to be this parabola shape right here. If I evaluate f of -8, I know it's going to be, when the x value is -8, go up to our graph, it's the line piece. It's going to hit the curve when y is 10. In other words, -8, 10 is an ordered pair on this graph. So when I plug in -8 as my input, 10 will be the output. -4 as an input, f of -4 would also hit the linear piece. When x is -4, y is 6. So f of -4 is 6. f of -1 is the red dot. The output's -4. For 0, the input hits the parabola at -4, so f of 0 is also -4. And then 2 is the input, the output's 0. 4 is the input, the output's on the parabola is -4 as well. Take a moment, make sure those make sense to you. And we're going to move on. Alright, so here's another piecewise function, different from before. The first expression is a linear, second one's a linear, and the third one is just 2. So we can evaluate these the same way we did before. F of -4. -4 is our x value, our input. -4 is less than 1, so we're going to use the top expression to evaluate f of -4. It would be -4 in place of the x, minus 4, and that would look like this. -4 in place of the x, minus 4. And we can simplify that, it ends up being 0. We could do this for any input. Anything between 1 and 4 will be evaluated with a 3x minus 6. And then anything greater than or equal to 4 will be evaluated with, or the answer would just be 2. Make sure these make sense to you, and we'll move on. Alright, another graphing one. So again, like we said, the first two expressions are linear, and the last one is just a value 2. In this case, unlike the previous one we graphed, the answer is 2 whenever x is greater than or equal to 4. Before it said when x is equal to a specific number, x is equal to a specific input, the output is 3. So when you have that, x equals 0 or equals some number, it's going to result as a dot on the graph. However, in this case, instead of x equaling a number, we don't have that. It's just x is greater than or equal to 4. And anytime any x value greater than or equal to 4, the answer is going to be 2. The output is going to be 2. So that's going to result in not a dot, but just a horizontal line. Input of 4 goes to 2, input of 5 goes to 2, input of 6 goes to 2. Anything greater than 4 would output as 2. And the other lines we can graph accordingly. Again, we're using our understanding of y equals mx plus b to graph these lines. Another way you can graph those lines is you could think, okay, what's if I start with knowing these are linear graphs, they're straight lines, I can plug in the low and the high values to kind of see where they start and where they end. So if I plug in the low value of 1 into 3x minus 6, I get -3. So 1, -3 is the starting point. If I plug in 4, I get 3 times 4 minus 6, which is positive 6. So 4, 6 is the other endpoint. So with the starting point and the end point, and with the fact that I know it's a linear equation, I could just draw a straight line and I would have that segment of the piecewise function. Anyways, this is the graph for this piecewise function. Go ahead and pause the video, make sure it makes sense to you, and then we'll move on. Alright, that's it for piecewise functions. Hopefully now you know how to read a piecewise function from a graph and from a function notation. Hopefully you know how to evaluate piecewise functions, again from a graph or function notation. And then we also now know how to graph piecewise functions. It's all about the domain. The domain. The domain.